In this lesson, we're going to learn how to factor polynomials. We're going to learn how to factor out the GCF, the greatest common factor. We're going to learn how to factor by grouping, which always works. And we're going to take a look at a few special cases. So before we begin, let's recall what a factor is. A factor is simply a number or expression that can divide evenly into another expression. For example, if we have the number 24 and we were asked to factor 24, or what are the factors of 24, we could have several factors. So 1 and 24, 2 and 12, 3 and 8, and 4 and 6. These are all factors of 24, and if we keep them as pairs and multiply them together, we get our original expression of 24. Factoring is the opposite of multiplying. So we're going to be undoing multiplication. We're going to be undoing the distributive property. When we are being asked to factor a polynomial, we are simply being asked what are the original numbers or expressions that were multiplied to create the polynomial. In our example, what two numbers produce the value of 24? We had several. 1 and 24, 2 and 12, we had 3 and 8, and 4 and 6. Part 1, we're going to factor a monomial from a polynomial. This monomial will be the greatest common factor. Factoring out a greatest common factor is always the first step in every factoring problem. So no matter what method we're using, you always need to ask, is there a GCF? If there is, we need to factor it out. Before we learn to factor out a GCF, let's see how it was produced. Here we have a monomial 6 being multiplied by our binomial, which gives us 6x minus 24 when we apply the distributive property. This 6 was the GCF of our new binomial. We multiplied 6 times x and 6 times minus 4, so we know that 6x minus 24 has a greatest common factor of 6. Here we're going to multiply this monomial by this trinomial, and this gives us 2x squared minus 8x plus 6. So in this trinomial, our GCF was 2. 2 can divide into each of these terms. Our last example of multiplying by a monomial, we get 3x to the third plus 6x squared minus 15x. The GCF was 3x. The monomial, what we multiplied by, is the GCF. So in the next problems, we will be given these type of polynomials and being asked to find the factors. We will be working backward. The factors will be the monomial and this trinomial. So let's take a look. Here's our first example. We have 18x minus 21. We ask ourselves, what is the greatest factor that 18x and minus 21 has? So I know that 3 can divide into both of these terms. 3 is the monomial, the GCF, and I bring it on the outside of the parenthesis. To find the remaining factor, we divide each term by 3. We're undoing multiplication. We have 6x minus 7. So these were the original expressions that produced this binomial. So the two factors of this binomial is 3 and 6x minus 7. In our next case, what can divide evenly into each of these three terms? I notice that 3 can divide into each of these terms. 3 is our GCF. 3 is one factor of this trinomial. The other factor is going to be 4x squared plus 3x minus 5. The two factors are 3 and 4x squared plus 3x minus 5. If I wanted to check myself, I could redistribute the 3 to each of these terms, and I should get back the original polynomial. You can always check yourself. In our last example, I noticed that 4 can divide evenly into each of these terms, as well as x. There is at least x to the 1 in each of these terms, so I'm going to factor out the x. 4x is the GCF. 4x is one of the factors of this polynomial. The other factor is x squared minus 2x plus 5. 4x and x squared minus 2x plus 5 are the two factors of this polynomial. Now you pause the video and try these. When we come back, we will do these together. Okay, in our first example, I noticed that the leading coefficient is negative. We always need to factor out a negative if the leading coefficient is negative. So I'm going to factor out a negative, and then I notice that 3 can divide into 21 and 24, and each term has a factor of x. So negative 3x is the GCF. It is one of the factors. The other factor is going to be a positive 7x plus 8. Again, we could distribute negative 3x to each of these terms and know that we have the right answer because it gives us our original polynomial. Our next example, I notice that 6 can divide into each of these terms as well as x. 6x is our GCF. It is one of the factors of this cubic trinomial. When I divide our first term by 6x, we are left with 4x squared minus 3x minus 1. Here are the two factors. Our third example, our leading coefficient is negative. I will factor out a negative. I also notice that 9 can divide into each of these terms. So negative 9 is the GCF. It is one of our factors. Always make sure to bring down your negative 9 or your GCF, in this case, negative 9. Now the other factor is going to be a positive 3x squared minus 4x plus 2. Here are the two factors. Our last problem, we have a cubic binomial. I notice that 5x squared is our GCF. That is one of our factors. The other factor is going to be 3x plus 4. So the two factors of this polynomial is 5x squared and 3x plus 4.